we are going to introduce a very important topic now, and that topic is inheritance. Let's draw a line here. So inheritance, you can think of a class can inherit properties from a more general class. One thing you might have observed that whenever we are defining a class like we did, for example, in our first lab, we defined an array class. So if you analyze what happened there is that you actually created a new data type, essentially, which did not exist before. Is it not? Previously, you knew how to do just when there are built-in data. These kind of types are called built-in data types, okay? These are called built-in data types like int, float, double, and char, and all these things. But when you are defining a class, you're then collecting more such either built-in or non-built-in data types together, and you're forming new types, right? After your lab, the first lab, you created a new type called array. And then you are able to, because of operator overloading, you can literally perform operations on them, right? So that was something like a, you can say like a general class you created. And these kind of ways of extending the data types is oftentimes kind of comes under the category of abstract data types. Now, are all classes that we are defining going to be abstract data types? Not necessarily, because abstract data types have one very important property, and that is that it maintains some kind of invariant. And not all classes need to be maintaining invariants. So we're going to touch upon this. I'm just very briefly just making this point. We're going to come back to this point later when we introduce the linked list, okay? But here I'm just making one very important point that when we are creating classes, essentially we are creating new types. And those new types that we create, they may or may not be abstract data types, depending on whether that class maintains some kind of invariant properties or not. All right. So inheritance gives us the power of taking such a general class and inheriting the properties and then adding some more properties to it. So for example, we created that shopping list, right? So shopping list can inherit properties from a more general list class. And list class could be just simply some sequence of items. But shopping list is a more contextual kind of list. So it is list first of all, but then something more than a list. Okay. So what C++ as a language brings in along with the inheritance is a very important, you can say, functionality called polymorphism. So polymorphism, so one method, so in polymorphism, one method calls one method call can work on several different classes, even if the classes may need different implementations. So example, so if I define a new method, say add item. So this method can be added to the list class. So you can think of, there is a list, my more general class. And then from there, I inherit a new class called shopping list. So this shopping list, so this list class had an add item method. This guy can also have an add item method. And which method gets invoked gets decided in the runtime. And I'm going to explain to you how the same add item function call can contextually represent either this add item or this add item because of polymorphism. So add item method, it works on every kind of list, even though adding an item to a shopping list is very different from adding an item to a list. Let's say some other kind of list. Say,
Pardon me, is this similar to the overloading, function overloading?
yeah, overloading is going to be function overloading is different concept. Function overloading comes that the same function with different function signatures, they can coexist. But here we are talking about these function signatures are the same, but they are applied across the function hierarchy, across the class hierarchy, sorry. Function overloading is that I can have add item taking int, I can have add item taking string, I can have add item taking pointer to int, and so on and so forth in the same class. So that's called function overloading. But polymorphism and so this, I'm going to more define what actually allows the polymorphism to happen. It's the virtualization of the function. So this has to do with allowing virtual functions to come into picture in the class hierarchy. Is that okay?
Yeah, I still don't understand it, but I'll roll with you and see where we get.
Yeah, sure. I'm first defining the term and we'll get into the specifics. So adding an item to a shopping list can be very different from adding an item to, let's say, a shopping cart. Because you can have another list called shopping cart. And this also has add item. So you can now have so many add items. And you want to be able to have full control over which add item contextually applies. Okay. So object oriented comes into picture here, that each object knows its own class and methods. So in the example above, so each shopping list and each shopping cart knows which add item method is used. All right. So just a couple of definitions, and now we are ready for jumping into practical stuff.